I'm going to start with Stephen Pemberton, who's a researcher, author, public speaker, and occasional broadcaster, and he's based at the CWI, which is the Dutch National Research Center for Mathematics and Informatics. Speaking broadly, his research is in interaction and how the underlying software architecture can better support users. So I'd like to bring Stephen up.
Not full screen. It was a presentation mode.
Presentation view.
That's the one. Try it. Do it again. Do the presentation view again. Yeah, that's the one.
Just took a few tries.
All right.
Thank you.
Thank you. Good evening. I'm Stephen Pemberton. If you think my English is good, it's because I was originally English, and I shan't be for much longer after Brexit, but I've been here actually more than half my life. As was said, I work at the CWI. You may not have heard it, but you certainly feel its effect every day because the CWI set up the internet in Europe. In fact, I was the 5th person in Europe on the internet because the guy in the office next to me set it up and he knocked on my door and said, the internet's running. And so I said, oh, okay, I'll log into a site. I'll go onto a site in New York. Yeah, it's working, thanks. And that was about it. We didn't, of course, realize it was going to be a historic moment because at that moment it was just for scientists and computer scientists. But it was fun to have been there. The other thing is that when the web came along, we were there waiting. In fact, I was doing research in exactly that area. So I went to the first web conference at CERN in 1994, December, and Tim Berners-Lee was there, and he said, would you please come and help us set up W3C? So in fact, I was there right at the beginning, which meant that I helped design CSS, and I chaired the HTML working group for a decade. So I'm going to talk about something to do with the web now, because I've been involved with the web since it first began. So I first want to start off with identity, because one of the big pains of using the web at the moment is all those damned passwords, and having to remember them, and having to do all those stupid characters and whatever. So I first want to talk about how you identify yourself on the web and how we could do it better. And to do that, I want to talk about public key cryptography. Now, I'm going to guess that some of you here know about it and some of you don't, which is why I'm going to just start from the beginning and explain how public key cryptography works. So in hotels, every room has a different lock, and someone somewhere has got this one key that works in every lock. Now, public key cryptography is exactly the other way around, that you just have one sort of lock and all the keys work in them, but once you've started locking keys, you have to do locking locks, you have to start doing special stuff. So there's one sort of lock, all keys work in all locks. Now, keys come in pairs, so that if you lock a lock with one key, you can only unlock it with its matched key, and vice versa. So both keys can lock, but if you've locked it with one, you have to unlock it with the other. And you can't tell by looking at the keys whether they're related. You can't tell by looking at one key what its other key would look like. They're very different. So, the other thing is that you can lock a lock more than once. So you can lock it with one key and then with another key. And to unlock it, you have to lock it first with the unmatched key of the second key and then with the matched key of the first key. So it has to be in the right order. So everybody in the world then, as it were, is given a matched pair of keys. And one is made public, which means that anybody can have a copy of that key, and one is private, only the owner can have it. Now, how do I use it? For instance, I write a message, and I lock it with my private key. And I send it to you with the label from Stephen. So that means that you know that I've locked it with my private key. So you get a copy of my public key, which you can do, and you try that key, and if it unlocks the message, then indeed it really did come from me. So in other words, that's digital signatures. You can guarantee that that message has really come from me. Now, there's another side to it as well, digital privacy. Because I can write a message to you, I can get your public key, lock it, send it to you. Nobody can read that message except for you because only you own your private key. You unlock it, you can read it. So I can be sure that I've written that message and that only you have read it or can read it. Which we can now combine because I can write a message, I lock it with my private key, I lock it with your public key and send it to you. I am sure that only you can read it. You're sure that I'm the person who's really written it. So it's guaranteed that no one else will read it. So we have secure messages. Okay, so that's the basis of what I want to talk about. Now, in reality, they're not actually keys and they're not actually locks. They're actually mathematical formulas with enormous numbers, pairs of numbers. And one number you keep quiet about and keep it to yourself, absolutely private. And the other number you say, this is my public key. This is how you write me a message. And in fact, when you use HTTPS on a website, that's actually using a single key system. But to work out which key to use, they use a public key system first, just to agree on the key. So, what are the advantages of this system? Well, for instance, if I order something from a shop, I can do it by sending a secure message to them. And I know that only the shop will read it. So, I've got privacy there about what I'm buying. But the shop knows it's also really from me. But then I don't have to give them my credit card number because what I can do is I can lock my credit card number with my private key and the bank's public key. So I know that only the bank can read that, and the bank knows that it's really come from me. So the shop doesn't know what my credit card number is, but the shop can send it on to the bank can read it and say, okay, I'll make that money over to the shopkeeper. But in fact, there's no reason to have credit card numbers at all, because if I just lock the message, please pay the shop 20 euros, then the bank knows it's from me, so they don't have to know anything about a credit card number. They can just sign the money over. Similarly, the shop doesn't need to know my address, because only the post office really needs to know my address. That the shop can put the stuff into the box and say, here's a message saying where it's got to go to, and the shop knows it's really from me and knows what my address is. It would also be a perfect way of dealing with spam email, because you would know if a mail really is from your bank. And it would increase privacy because only you could read it and nobody else. But why I'm talking about this now is for identity, because if we use this, we wouldn't need passwords anymore. Because I can log into a site and I say, hi, I'm Stephen, however I do that. And the site, as it were, says, oh yeah, here's a message encrypted with your public key. Tell me what it says. So, I mean, that's being done with a protocol, but my browser decrypts the message with my private key and sends it to them, and they recognize that it really is me and lets me in. In other words, I've got a private key, and my browser can access my private key and get me into websites without me ever having to type in a password. That's part one. Oh, and yeah, I should say, of course, your private key are your crown jewels, because if anyone gets their hands on it, then you're done for, or you have to, in fact, revoke all your keys and say, okay, I'm changing my private key, but that's a real pain to have to do. Okay, so part 2 of 3, I want to talk about the social web. So, what is Facebook? Apart from a really centralized place that's turning into a walled garden of information, what does it allow you to do? It allows you to record things. I mean, ideas, photographs, videos, whatever. It allows to say who your friends are, and it allows you to say which things of yours can be seen by which groups of friends. And it also allows you to look at what your friends have recorded in the same way, on the other way. The only player that you can't stop from looking at your data is, of course, Facebook. And the problem is that they own your data, and they use that data for working stuff out about you. For instance, I read recently that even if you don't say whether you're single or not, they work out from your data whether you are or not, and then start feeding you suitable adverts like dating services. Of course, this is not nice. I mean, you know, I won't deny the value of Facebook because I've got in contact with friends that I'd lost for years, and tomorrow morning, I'm off to go on holiday with a bunch of school friends that I'd lost contact with, and we managed to get in touch with each other via Facebook. And so, I don't want to deny that it has some value. But the problem is, it's nasty. It's not what we really want. It's centralized. They're doing stuff with your data. You don't know what they're doing with your data, and you've got no control over it at all. So, how would we do Facebook decentralized? Well, it's actually rather easy. You store your stuff, and you can have a program to help you in just the same way that Facebook does it. You just type stuff in and up it comes. But you store it locally. You don't store it on Facebook's servers. It doesn't matter if it's your own machine at home or if it's on a hosted machine somewhere. It can be a hosted machine anywhere. You also store locally who your friends are, along with their public keys. You tell the system, again, who can see what, and the system then allows your friends to log in, as it were, using the public-private key method I just talked about. They can see your stuff in exactly the same way, but it's your data and it's on your machine. Similarly, they're doing the same stuff, and you, or your program on your computer, can go off and get their stuff and then display it to you in exactly the same way. There's nothing special about Facebook in that respect. It just gets all the data from different places and then shows you your version of it. No one owns your data. You're not logged into Facebook's algorithm. There are no adverts. It doesn't cost anything except the hosting. So it seems to me like it would be very easy to do this. Part 3, HTTP. Now, HTTP is the protocol that's used on the web. It's been here right from the beginning. It's served us very well for the last, whatever it is, more than 25 years. But it's beginning to show its age. And the problem is, it's become a single point of failure for content. So HTTP, it works client-server, your machine goes off to the server somewhere using this protocol and says, give me this stuff, and there are all sorts of replies that it can give. It's very simple to implement, and it's served us very, very well all these years. But, as I said, it's a central point of failure because, for instance, it's very easy to break with a distributed denial of service attack. It's very easy because it's all centralized in one place. It's easy for governments to monitor, block, and close sites because it's all in one place. It's a problem because it's not built for load, and so popular sites have to quickly distribute the requests over lots of different machines in an invisible way, but they have to do a lot of work. If you've got a popular site, then you have to do a lot of work behind the scenes to turn this simple protocol into something that shares the load over lots of machines. If you're a small site and suddenly somebody /dots you or Reddits you or whatever, you get an enormous peak of demand, and because of that previous thing about popular sites have to use load sharing, if you weren't a popular site and you suddenly become a popular site, then your site can easily crash or become unavailable just because everybody's pounding away at your machine trying to get the data. And another problem with HTTP is that URLs keep changing, which they shouldn't, but people seem to think that they can move their content to a different place. And so you might have a URL of a bit of content today, but in a year's time, they've moved it somewhere else and you don't know where it is. And you see this on Wikipedia all the time, that somebody's put a link to something and you click on it and it says content not available. So it's one of the problems of HTTP that links can move and then you've lost the data. So there's a way that you can do better, and that's using peer-to-peer. Peer-to-peer, of course, has got this background idea about it being about piracy, but it's not at all. It's an extremely good protocol for sharing content over lots of different machines. Because all these different machines are sharing the content with each other, it means it's very hard to block. If you've got a piece of content that the government would like to block, it's hard to locate all the places that have got it, that are sharing it. You can't just go to one place and say, right, we're closing you down. Peer-to-peer is also good because the more popular a particular piece of content becomes, the easier it is to find because it's coming from more places. It means that if the originating site goes offline, it may well be that you can still get to the content because there are other people who have got it who could share it. It means that peaks of demand are automatically dealt with because the more people who ask for it, the more people who are able to share it. And the last point is that popular sites don't need to buy huge data pipes in order to serve their data. You can just serve it along a small pipe, and because lots of people are coming and getting it, they're sharing it with all the other people, so that the data is coming fast to you, even though the originating site doesn't have a wide pipe. The other part to go with this is not using HTTP links, but using magnet links. Now, these exist already, and the nice thing about magnet links is that they tell you, they define what you want and not where you want to get it. So, I think I've made this one up, but it's meant to represent the text of Ulysses by James Joyce. So this long number here is basically a summation of all the characters of Ulysses. So it's a sort of key to that piece of content. And so what happens with magnet links is that the link goes out across the world and saying, have you got this piece of content? And the peer-to-peer servers that have got it then can start serving it. The last bit, though, is if nobody's got it, then at least there is a single place that you can fall back to get that data. Now, if somebody's got a piece of data or a piece of content that you're asking for, then they can serve it to you because they've downloaded it from somewhere else. And if several people have got it, then they can share it to you at the same time, making it even faster than just getting it from a single place. Now, there's a good example. I just want to show you one example of a sort of browser that does exactly what I'm talking about. It's called Tribler. I'm showing it here being used for streaming films, but you can use it for any sort of content at all. So what I've done here is I've just searched for "It's a Wonderful Life." The reason I searched for that one is that it's out of copyright, and so no one will be able to arrest me for downloading stuff that was in copyright. So I've searched for it, and it's found the film, which you can see in the player over there. Now, what happens is that when you start streaming it, it starts downloading it peer-to-peer. That is, everybody who's got a copy of it starts serving little bits of it. And so what you can see here is that it's 799 megabytes long, of which we've only loaded 50 megabytes so far. The blue lines are the bits of it that it's already downloaded. But what you can see is that it's concentrated first on the first parts of it, so that you get the beginning before you get the end. Even though some middle bits have started appearing, it's been concentrated at the beginning. So what this means is that while you're watching, you can start watching at the beginning, and while you're watching the bits at the beginning, the bits in the middle start filling up. So you can see we're now at 22%, and you can see more and more bits coming in. But again, it's still at the front that it's downloading it the fastest. This is good. So we still need HTTP for the long tail, for the bits that people don't have, for the single use pages. But it's good because it's hard to block, it's much faster, it's much cheaper to run if you're serving data. It increases the availability of content. It's resilient to peaks of demand. Because it's still using the web in the same sort of way, you can phase it in without any disruption, so you can still continue to use the old web while you bring the new stuff in. And even though there are some problems with personalization, because that makes a single page that nobody else has, You can create personalization by having the bit that everybody has and the personalization bits. And so you can still share the template and just add in the personalization at the last stage. So in conclusion, the web was actually designed as a decentralized system. And unfortunately, slowly, it's become more and more centralized as people like Facebook and Google take it over. But it doesn't have to be like that, and we could take back control. There are some fairly simple things we can use using existing technologies that would make it all very much better. Thank you.
So there's room for 5-minute questions, so maybe 1 or 2. Who has a question for Stephen? That's your chance. Nobody?
It always takes a few seconds for people to think.
Okay.
Go.
Thanks. Good running, Anya. What would be your suggestion for the first thing that someone can do to make the biggest change in their internet, in their internet use? Like, what's the first change I should make in my online behavior?
Well, I'm not asking you to make a change in your behavior here. I'm saying that we have to make a change to the infrastructure. But this is the way that we can do it. My suggestion would be to build the new Facebook, because that's the most pressing issue at this moment. In fact, the original internet, as it was designed, or they wanted to use public key cryptography, which would have solved so many problems now, because we wouldn't have had spam, we wouldn't have had to have all these passwords. But unfortunately, when it was originally designed, and we're talking about the 60s, to do public key cryptography meant having to do it in hardware, which would have meant the connections would have been immensely expensive. And so they didn't do it. So really, we should redesign the infrastructure of the whole internet. But that is more of a problem because that's so deep in the built in the hardware. But with the web, it's not built in the hardware, it's built in the software, and so we can change it at that level.
Thank you. There's another question here.
I really want this, but like, how do you get network effects when people can't encrypt? Like, people have trouble with PGP email, much less using it for just internet usage.
Well, yeah,
I mean, implement it.
Yeah, I agree. I mean, this is interaction design. I think PGP was designed by nerds who didn't understand the principles of user interaction. That doesn't mean to say it's a bad idea. And what I'm trying to suggest here is that it's completely invisible to the user because it's going through the protocol that the browser uses. The browser, I mean, you might have to type in a password to allow the browser to get your private key, but that's where it stops. Having done that once, you're in a session with the browser has access to your private key and can then communicate with other sites without you not knowing about it at all. That already happens with HTTPS, but we need it to go just one level lower so that it also works instead of passwords. So I believe that you can get the network effect, but we just have to do some work.
And when you say we, who do you mean?
Hackers, designers.
There's one more question. Oh, yeah.
I'm going to sneak in 2 questions. The first one is, I think, the obvious one, which is why Google became so successful. Search on a peer-to-peer system, I think, is potentially hard. And 2, are you following any modern technologies like IPFS? And
I didn't catch that, sorry.
IPFS.
What about it?
Are you following it? Do you have an opinion on it?
I can't say anything sensible about it.
Okay, so search. What do you think about search?
So, well, why did Google become successful? Because they did it better. I mean, there's no doubt that the moment that they did it, firstly, their homepage, as it were, wasn't packed full of adverts. It was just a search box which made life that much easier and also much quicker to get to. And also their algorithm for searching was that much better. But that doesn't, this doesn't stop you searching. It doesn't stop you finding content. In fact, Tribler shows exactly that, because they do have search built into Tribler that finds the content that's being served via peer-to-peer. So it's a different way of searching, but it's not excluded. Oh, that was the last question. Right.
Thank you
all very much.
Thanks.